Hi everyone, my name is Suryavan Singh Hara. I'm a fifth year PhD student at UCMS Computer Science Department, and this is a paper Style Transfer by Rigid Alignment in Near-Net Feature Space. And this is a joint work with my advisor, Professor Miguel. And that's it. So the goal of this paper is to perform effective style transfer in real time for any arbitrary pair of content and style image. With that said, most of the work in this regard can perform style transfer in real time, but they fail to provide good results. They either do insufficient style pattern transfer, such as add-in, or introduce content distortion in during the process, such as Ethernet and WCT. As we can see, the nose has been distorted in the final styled image. So we need a method that can sufficiently transfer style patterns without introducing content distortion. Like this image, as we can see, sufficient patterns have been transferred, and there is no content distortion. With this said, our paper is based on two hypotheses. First, working in deep neural network feature space can transfer texture and other high-level information from one image to another without altering the image structure much. This is an implicit hypothesis which has been used by many previous works. And the second one is, if we consider images as a collection of points in feature space, where each point represents some structural information, and if we align these point clouds using rigid alignment, we can transform these points without introducing any distortion. And here we align style feature to the content feature. And our experiment result shows that indeed this hypothesis is also true. With that said, our overall approach has two parts. First, similar to add-in, we perform moment matching between the features. This helps to transfer low-level style information such as colors and low-level strokes. And now in the second part, which is the important one, which is the rigid alignment. For this, we consider features as a point cloud of size C, where each point is in SW space. And this is the only valid configuration for the style transfer. Any other configuration will lead to complete distortion of content in the final styled image, as we can see here. The reason for this is each point in SW space contains some structural information about the content, which is required for effective style transfer and image reconstruction. And this information is not present in any other configuration. That's why we need to arrange the features in this specific way. With that said, once we have the point clouds, we apply rigid alignment to style points with respect to the content point cloud. For this, we apply shifting, scaling, and rotation to the style points with respect to the content. And in the end, we achieve ZSC, that is our final style feature. We pass it to a decoder to get our final style image. That said, let's look at our experiments. So as mentioned above, add-in is unable to transfer the sufficient style patterns that can be seen in row number 3, where as you can see there is style is very poor. On the other hand, both add-in and WCT do sufficient style pattern transfer, but in that process they introduce a lot of content distortion, as can be seen in the top 2 rows. Especially in this first row, it's impossible to tell a difference between clouds and the mountains. On the other hand, the proposed method not only transfers sufficient style patterns, but also preserve the content structure, as can be seen here. So in conclusion, our proposed method can achieve effective arbitrary style transfer in real time without introducing any content distortion. Second, it does not require training another neural network for the style transfer. And the third one is it provides a closed form solution to the style transfer problem. With that, I finished my presentation. Thanks for your time.